For many, the herpes simplex virus type 1, HSV1, is a familiar and mostly benign virus, often manifesting as cold sores. It usually lies dormant in the body after an initial childhood infection, with occasional flare-ups triggered by stress, illness, or injury. However, new research is raising alarming questions about the long-term consequences of this virus, particularly in its potential connection to Alzheimer's disease. Over 30 years ago, researchers discovered something surprising. HSV1 could be found in the brains of older individuals, a finding that contradicted the previously held belief that the brain was a sterile, virus-free environment protected by the blood-brain barrier. What's more, the presence of this virus in the brain, particularly in people who have a specific genetic variant known as APOE4, appears to significantly increase the risk of developing Alzheimer's disease. This genetic variant is already associated with a heightened risk for Alzheimer's, and when combined with HSV1 infection, the risk multiplies significantly. The troubling implication is that the cold sore virus, typically dormant and seemingly harmless, could be a silent player in the development of Alzheimer's. Researchers discovered that brain cells infected with HSV1 produced abnormal proteins, amyloid and tau, which are hallmark signs of Alzheimer's. This suggests that the virus may contribute to the production of these harmful proteins, leading to the progressive damage seen in Alzheimer's patients. While the virus may remain dormant for decades, it is believed that as the immune system weakens with age, the virus can reactivate and enter the brain. Once there, it causes inflammation and damages brain cells, potentially triggering the onset of Alzheimer's. Repeated flare-ups over the years could accumulate enough damage to lead to the neurodegenerative disease in certain individuals, particularly those with a genetic predisposition. Strikingly, research has also found the DNA of HSV1 within the amyloid plaques that are characteristic of Alzheimer's brains. This offers a clear biological link between the virus and the disease. Encouragingly, researchers have also explored antiviral treatments, which in laboratory settings have shown promise in reducing the damage caused by HSV1 in the brain. This opens up the possibility that antiviral drugs might one day help slow or even prevent the progression of Alzheimer's, particularly for those at higher genetic risk. The connection between viral infections and Alzheimer's is not new, but the idea that HSV1 plays a direct role in the disease's development adds a new layer of complexity and hope for future treatment options. Further studies have also suggested that other viruses, such as the varicella-zoster virus, the cause of chickenpox and shingles, may also be contributing factors. Intriguingly, studies on the shingles vaccine have provided another piece of the puzzle. Individuals who received the shingles vaccine were less likely to develop dementia, suggesting that preventing viral infections could lower the risk of Alzheimer's. This finding further strengthens the case that viral infections, including those that remain dormant in the body, might be a crucial, yet often overlooked, trigger for Alzheimer's. While much of the research remains in the early stages, the evidence is compelling. It suggests that infections, especially those caused by viruses like HSV1, can activate hidden viruses in the brain, contributing to the neurodegeneration associated with Alzheimer's. The key takeaway is that it's not just the presence of the virus, but also factors such as infections, head injuries, and inflammation that could lead to the virus reactivating and causing harm. This research highlights the need for more cautious consideration of the role infections play in Alzheimer's. In particular, it serves as a stark reminder of how a common virus like HSV1, which many of us carry unknowingly, might have more serious consequences as we age. For those at genetic risk, the stakes could be higher, making it all the more important to consider ways to prevent or reduce viral infections throughout life. The long-term implications of this research are profound. It opens the door for potential new approaches to preventing Alzheimer's, including vaccines and antiviral treatments that could target the virus before it causes irreversible damage to the brain. In the future, we may look at Alzheimer's not just as a genetic or age-related condition, but as something that can be influenced or even prevented by controlling viral infections. While this connection is still being explored, the findings suggest a shift in how we approach the prevention and treatment of Alzheimer's disease. If confirmed, this theory could radically change the landscape of Alzheimer's research, leading to breakthroughs in both understanding and managing the disease. The idea that something as common as a cold sore virus could play a key role in one of the most feared diseases of our time is both troubling and hopeful. With continued research, it may one day be possible to turn the tide on Alzheimer's, preventing its onset before it ever takes hold.